Hi, today we talk about vector field to determine whether it is conservative, and also we need to find its potential function at a symbol like this. So the key takeaway is if the vector field is conservative, it is equal to the partial derivative of itself. Okay, so for a vector field, it can be in terms of two variables or it can be in terms of three variables. So if in terms of three variable, it should be in something in terms of I unit plus something in terms of the J unit plus the something in terms of K unit, which is the X, Y, Z unit vector. So we can say that to make it simple, you can think it's a first part, second part, and third part. All we can estimate is be the first part here in front of I is F. This part is a G, and this part is as H. Okay. Let's see how we're going to do it. First example, for vector field in two variables. First, is equal to square plus 1j. Alright, so we just say this part as f, this part g. But actually it's very simple. We just differentiate in respect to the opposite. If this is in terms of I means x, then we need to partially differentiate this one as the opposite, which is y. And if this is in terms of j, means this is in y-axis, then we partially differentiate this one in terms of x. And the both sides should be equal to each other. And if this is correct, then we can say this function is conservative. Okay, so let's get started. So we take the first part here in front of I, this part, then we're gonna partial derivative in terms of the opposite. If this is x, then this is y here. Then we should get 12 because this is 3 times 3, 4 times 3 is 12. X cubed is remain. We view this one as constant, and then y square, and this is a number, then it's nothing. Then the opposite part here, that's partial derivative of g. If this is in terms of y-axis, then partial derivative in respect to x. Then we got 4 times 3, we got 12. X cubed, y square, and this is a number. If we differentiate, we got 0. So here we can say that this part is equal to this part, and therefore this vector field is conservative. All right, cool. Let's say it's also two variable, easy first. This part is in term of I, so means x-axis. Then we do a partial differentiate in respect to opposite, which is y. So y squared differentiate we got, because here they got two terms. We can two terms, one term and second term. We have to differentiate using the product rule. So we can copy this one, and then we differentiate the opposite. Differentiate cos xy, we should get negative sine xy squared. And because this is the function, inside got the function, then we just change root times the derivative of inside this bracket xy squared in respect to y, then we got 2xy. Okay, not yet done. And we add, we copy the opposite and differentiate the other side. Differentiate y squared, we got 2y. And we're gonna summarize this. Okay, so y squared times y, so it's y cubed, and got 2x here. I'll put it here, and then put it nicely, plus 2y cos xy squared. Yeah, and I can put the negative sign in front. this. Okay, so see whether you want to factorize the y up. Okay, then next, and this part is in terms of j, means in we're gonna partial derivative this in respect to the opposite is which x. Then same, we need to use the product rule since this is a function of x, a function of x. So we copy one side, differentiate the other side, differentiate sine xy squared. We should get make it quick 2y squared because we times the inside, and then cos xy squared here, and then we add up and copy sine xy squared and differentiate the opposite is negative 2y. Then we're gonna make it nicely. 2 times 2 is 4. Y times y squared is y cubed. Okay. Alright, so I make this in front here. Negative 2y sine xy squared. Okay. But we compare these two terms, this term and this term. So they are quite different. This is in front of the cos, this is cos. Y is 2y is 4, negative 4xy squared. So we can say that both are not equal. Both are not equal. Means they are not conservative. So therefore they are not conservative. Conservative. Okay. Next. This time in terms of three variable. This should be a more complicated step if it's in terms of three variable. We have I, J, K. In order to test it, there will be a complex formula. But I wouldn't recommend you to memorize it. I'll teach you a trick to remember them. So it's at first time will make you feel shocked is of this complex thing, but actually it's quite simple. So the concept is like right now we have three terms, then we're just able to compare two terms. So we can take the first two terms we compare, or we can take the second and third terms to compare, or the first and the third term to compare. If all these three satisfied, then this vector field is conservative. Okay, so for example, I take this one. Okay, if this is in terms of I, then we are differentiate in respect to the opposite is y, and this is y, then I'm gonna differentiate in respect to x, and as for we have this one. Moving on, next we take the second and third term. This is in terms of y, then gonna differentiate in respect to the opposite, which is z here, and this is y. So that's why we got this term here. Next, if we take the first and the third term, then we're going to differentiate in the opposite. X we differentiate in respect to z, and z we differentiate in respect to x, and therefore we got this term. So the concept is simple, and we don't need to memorize such a complicated thing to burden your brain. So let's get started. Let's say I take this one to verify first. Then I differentiate in respect to y for this term. So y differentiate, I got 1. Y z I differentiate, I got z. And this one is in terms of x up. And differentiate is 1 plus this doesn't have any x, so it's 0. Okay, I have to write it. And this one differentiate, I got z. So these two are the same. We can say df dy is equal to dg dx. So the first test is pass. Then we do on the second test, which is second term and the third term. So in this one, we differentiate in respect to the opposite, which is z right now. X doesn't have z, so it's 0. So this one times 9z squared plus x. And for the opposite, there we got 9z squared and then plus x as well. So we can say both sides are the same. So satisfied our test. All right. Then the last test is the first term and the third term. So the opposite. Y is a constant. It doesn't have any z, so it's 0. And this one, we differentiate, we just got y. And this one, sum of x. So there's no x here, so 0. Then just one x, y, and this constant. So both are equal as well, y equal to y. So it's satisfied, means this vector field is conservative. All right. Okay. So I'm going to talk about potential function in the next video.